exact differential forms. The integral depends on the limits a and b, and it is passed in. But there's a second integral which is not so well known in economics. This is the Stokes integral of not exact differential forms. And this integral is path dependent. And there is no stem function. Why? Because a different path will lead to a different result. So this function has no, there's no stem function. And these two integrals correspond to ex ante and ex post. And there is an integration law that tells us that a not exact differential form delta y may be related to an exact differential form df by an integrating factor. And you see there is delta y lambda df, and this replaces actually y equals f. It cannot be functions. These are not exact differential forms. And income is a typical non-exact differential form and a Stokes integral. So there is no stem function. Let me quickly talk about closed integrals. The closed Riemann integral is always 0. The path from A to B is equal to the path from B to A. It's path independent, so it's 0. It's like a ring. After the end, you are at the same place again. The closed Stokes integral of non-exact differential forms is never 0 because the path from A to B is not equal to the path from B to A. So it's something that is not equal to 0. Let me give several examples of a closed Stokes integral. Let's take a household working in industry, earning €100 or $100 per day and spending $90 for food and goods. And the surplus is €20 or $20. So this is actually the first circle, industry, and I have it here. This year, industry pays income to households, and households pay consumption costs to industry. But this is 100, and this is 90, so the balance is 10. And this is the typical Stokes integral, delta m equals y minus c. This is y, the upper path is y, and the lower path is c. And the difference is delta m. This is actually the output of this integral. You can write this as an Excel equation here. And you see this is not, Victor. This is not a circle, it is a spring. The Stokes integral is a spring because after each day, the family is €10 higher. The next day again €10 higher. Again. So these Stokes integrals are springs and not circles like the Riemann integrals. Then we take another example, or three other examples from for Stokes integrals. In biology, we have the blood circuit. The blood circuit in the arteries carries carbon and dioxide as energy, and the veins on the way back carry carbon dioxide. So the difference in energy goes to our body. In physics, we can withdraw heat from with little energy from a cold river and heat up a warm house, and then withdraw again with little energy heat from a cold river and heat up a warm house. This is called a heat pump, and that's very effective. In economics, we have the same pump. This is, you can invest little money in producing in China, and you can sell for much energy, for much money, and sell in the States. And then you take a little money of that, invest again in China, and then you sell it again for a large profit. So this is also a Carnot process. These are all three Stokes integrals. In physics, we call this a Carnot process, and actually these three are all Carnot processes, like the Chen just told us just a minute before. So I will now talk about the laws of macroeconomics. I will start again with the household working, earning 100 and spending 90 and having surplus. The first monetary account is 100 minus 90 is 10, but they don't get the 100 for nothing. They have to work and do work, labor, and then they spend money for 90, but they get, of course, goods, food, whatever, for 90. So in the double entry accounting, the sum of these is always 0. The sum of the monetary account and the productive account is 0. Because you always pay for what you get and you get for what you pay. And this is actually in monetary units, the productive account, work and food is actually measured in energy. But in economics, it is calculated in monetary units. The monetary account measures the productive account in monetary units. So, and this is actually, since we can write these integrals, these extra accounts as closed Stokes integrals, this is actually the basic law of economics. The monetary account measures the productive account in monetary units, and the sum is 0. And from this integral, I can deduct most of the problems I want to in economics. Let me show you how this works. I write this law first again separately. This is a fundamental law. And then I write this first law. If I do assert the closed integral again, I have this here. If I do the closed integral of this, I have this up here. And if I do the closed integral of here, this is an exact differential form. This is a Riemann integral, and the closed Riemann integral is 0. So this one drops out. So this is now the first law that comes out of this. It tells us profit is a function of, is depending on capital and labor. This is the differential double entry valence of economics. We know that already that capital and labor are the main input data, but now we have written this as a differential equation. And this is new. We can also write a second differential equation because a not exact differential may be written as an exact differential multiplied by an integrating factor lambda. This is just calculus in 2 dimensions. It is very simple actually. So these are the two laws that come out of it. And this second law is the proof of existence of a production function in economics. Because for every profit we make, there is a function, and economists call this function production function. So there is a production function, and we will later see how it looks. We now have the laws, the fundamental laws of economics. There are one integral law or two differential laws, and they are all measured in monetary units. Now I will turn this around and say I will measure the monetary account and say the productive account measures the monetary account not in monetary units but in energy units, because production is in energy. And we turn this around. We can do that because we can transform energy in money by the oil price. At the fixed price, and we can just calculate energy by the oil price and turn it into money or the other way around. It changes every day, but you can still do it. And this is the way of connecting these. And you see, I've changed that the labels or the numbers or the letters actually, but they are the same letters as at the other side. It means the same, except now I have written the laws of economics in energy units. And this is now actually the energy units. And what we look, if we look at this, we find these are exactly the laws of thermodynamics. We have the first law and the second law of thermodynamics, and these laws are sufficient to calculate everything we want to in thermodynamics. And what we find now is in economics we have surplus, and in physics corresponds to heat. Capital corresponds to energy, labor corresponds to work, the production function corresponds to entropy. Now we know what the production function is. And the standard of living corresponds to temperature in physics. That we can do this, we can look here at the economic data and the energy data. Here we have the GDP per capita compared to the energy consumption per capita for the 126 biggest countries in the world. And GDP and energy run exactly parallel within a certain limit of error. So this proves that really energy and GDP is equivalent.
They don't. I'm sorry.
Well, we can discuss it, okay?
So many things to discuss here. I think we better start the discussion because there's certainly
No, I will, sorry, I may.
You cannot go much longer.
No, I will, but.
2 minutes.
Yeah, okay,
2
2 minutes.
Now, otherwise, the other speakers don't get their time.
I will just finish this.
Please.
Now, we have now this.
Making a lot of statements which I don't agree with, and I think
yes.
so.
Okay, we have now an example. I will show the production according to these two laws. I have here the production of coal in South Africa. What we find is we first can collect coal in South Africa, put it to Cape Town, and there we have a big pile of cheap coal. And there we bring it now to Antwerp, and there we have a big pile of expensive coal, because coal is more expensive in Europe than in South Africa. And from there we distribute this to the customers. And now this is the production circuit, and now we have the monetary circuit. We'll finish this in a minute. The importer will collect the money from the customers, and then he will send it to the exporter, but of course not everything, he keeps some for himself, and the exporter brings it to his workers and keeps of course some for himself, and the foreman has something, has to buy a car, can buy a car, and now we have finished the both circuits. And what now happens is we have here again this monetary circuit measures the productive circuit, and what happens now is the following. The gains are distributed to the both sides, and this makes economic growth. This is because the gains are distributed to the poor and the richer side. This leads to economic growth, and what we find here is that production is a Carnot process. We always have two separate levels. In companies, we have capital and labor. In trade, we have buyer and seller. In banks, we have investors and savers. In societies, we have rich and poor. Like in motors, refrigerator, heat pump, or generator, we always have hot and cold. And if both temperatures go together, like if we open the refrigerator, this is communism. Communism mixes the income of production to the producing world, to the one class, and this means if we have not two levels, then we open the refrigerator and the refrigerator will stop working because it needs two levels of production. And this is my message. Production needs two levels. It would be nice that everybody gets the same, but the more efficient is the hotter the efficiency of the system is the difference of these levels. The higher the temperature of the motor, the better it runs. This is the grizzly bear Tim was talking about. Whereas if it's a little, okay, I will stop. I'm sorry.
Thank you.
Okay, thank you
very much. Why don't you start with the solo function as being incorrectly specified, and production isn't a function of capital and labor, it's a function of capital, labor, and energy.
No, because energy and capital are the same thing.
No, capital is a means of using fossil fuel.
Okay, yes, then the fossil fuel is the energy.
Yes.
Yeah, so you have only two variables.
Well, plus the energy
work.
to make the capital, etc. But okay.
Yeah, no, you only have work and you have energy. And the only law that handles work and energy is the first law of thermodynamics.
Excuse me.
I made my point, but
I studied physics before you did. And I've been in economics for 50 years, and almost not a single statement that you made is correct.
I don't think it's
So,
a responsibility
must not.
of here doing that.
Let's go
Yeah,
on.
these are new theories, I agree.
It's not right, it's just wrong, that's all.
Well, you show me one
I
single
can do
one.
that, but not here and now.
Okay, well,
Well, the survey, I think we'd like to hear just one statement of the incorrectness, just for the record. Just a quick point where he was incorrect, just so we can all learn from your one quick statement.
Well, for one thing, energy is a factor of production. Talk to your colleague, Rainer Kummel in Würzburg.
yeah, I talked with Kummel a lot of times,
Yes.
and I know Kummel.
And you don't agree, obviously.
But I told him that he's wrong on that point. And, yes,
And he'll tell you that you're wrong.
no, but you.
Professor Ayers, just do your chair duty, don't do it.
I'm trying to.
Yeah.
I'm really trying, but this is too much. Yes, please. Yes, back.
Would that mean that labor has nothing to do with energy? Would your model,
Pardon?
would your model be saying that, or this calculus be saying that labor has nothing to do with energy?
Labor is separate. You do not need.
Yeah, it's just a yes or
Yes.
no question.
Yes.
Does labor have anything to do with energy?
But labor makes potential energy. If you labor, you get potential energy, because this is what you, if you have a machine that labors, then you can pull up stones high, and this is potential energy.
My question was more about.
That is not what labor is used for.
Okay.
It was
But we have
50
to
or
change
100 years
that.
ago.
Because we have
This
limited
Yes, I
time.
know.
Only because we have limited time. At the end of this, we can all engage in a lively coffee hour conversation with